Welcome to Lesson 8A, Temperature Inversion Reflecting Ground, Part 2. Now we're going to have some fun because we have to add a lot of sources. If we have a Gaussian plume with an elevated temperature inversion and a reflecting ground. So let's start with this equation we had previously. We have a Gaussian plume with a reflecting ground, and now we add the elevated temperature inversion. So here's our setup. We have our stack with our buoyant plume, and so there's our real source. We already put a source under the ground to account for the reflecting ground. Then we added another source up here, and that one is accounting for the reflection off the bottom of the elevated temperature inversion. So that's this one. So we had to put an image there. But are we done? Well, no. If you think about it, any source has to have a corresponding image source through the reflection, in other words, a mirror image of it. So let's label a couple of these. I'll call this one 0. It has a reflection to under the ground. We'll call that 1. But now we also have to have this reflection here, and I'll call that 2. But if you think about it, you're going to have to reflect 2 across the ground because that's a reflection, that's a mirror image. And that one's going to go down here somewhere, and that will be 3. Okay, are we done yet? Well, no, because this source 1 has to reflect off of the elevated temperature inversion to account for that. So we go from 1 and we mirror image off of this green dashed line. So we're going to go way up here somewhere to 4. So with 4, the distance from the elevated temperature inversion to the source at point 4 has to be the same as this distance here. So you can see the geometry is getting a little complicated. Are we done yet?
I think we will need even more image sources.
You are exactly right, Ned. We have to have an image through each reflection. So we're reflecting across this temperature inversion, which is kind of a lid, and we're also reflecting off the ground. So any source that we have above the ground, any of these images, including the real one, have to reflect back down below the ground. So you're going to have to take this 4 and go back down here to some 5. You're going to have 3 over the bottom of the elevated temperature inversion, and you could see that this is going to involve many image sources.
I'm afraid that this will never end.
That's right. It turns out that we need an infinite number of images in order to mathematically model this properly. I'll make an analogy with mirrors. I took this photograph in my bathroom mirror, and you can see what I did was hold a mirror up to my bigger mirror and take a picture, and so I couldn't align it perfectly and still take the picture, but you get the idea. You actually need an infinite number of reflections in order to get this to work properly. So that's what we're trying to do here. And I think you can see that what happens here is all the smoke gets trapped here between the lid of the temperature inversion and the ground. Since the ground is reflecting and the elevated temperature inversion is reflecting, this is called a fumigating plume. And I should point out that this is the worst case possible because we've trapped all that air pollution. It has nowhere to go vertically once it fills up that entire distance, which we call HT. Once it fills up HT, it's trapped there. Since everything hitting the ground is reflecting, everything hitting the temperature inversion is reflecting. So you have the worst possible case. This would give you the biggest mass concentration of any of our plumes that we've talked about on ground level or anywhere else, any other elevation within there. So how do we get all these locations? Go back to this equation and realize that every time we had a source, this was actually z minus the location of the source. So I'll call that a z source is equal to h. So that's the location of the source. Here we have z minus negative h. So this is the source. Z source is at negative h. And so we can do the geometry here. We can see this z is h, this z is negative h. Number 2 here, we had z equal negative h plus 2ht. That was from our previous lesson. And then you can keep doing this. This 4 here would be z equal h plus 2ht. Again, just doing the geometry here. This one down here, which I called number 3, would be at z equal h minus 2ht. So you can do the algebra, the geometry. It's just adding some of these things up. Anytime you reflect off the ground, the distance between the image and the image above, the image below and image above has to be identical. And anytime you image across the lid, the elevated temperature inversion up there, you have to have equal distance, like I drew with those blue arrows there for number 4. So between 4 and 1, those are the same distance from the elevated temperature inversion. So here's what it looks like when you add an infinite. Obviously, I can't draw an infinite number, but you get all these sources, and I had labeled these previously as 0, 1, 2, 3, 4, and you have to do that forever. And we have to add up all these sources, including I equals 0, which is the real source, and actually the first one, number 1 and number 0, are from I equals 0. Let's do the geometry. I'll just do these first 4 that we've talked about. This is just a matter of drawing this and adding some heights up. For each source, I'll give you the z of the source, the location of the source. So for 0, that one's easy, that's at h. For source 1, which is our reflected source, the real source reflected because of the reflecting ground, it's negative h. Number 2, which is this first one up here, that's the same as our previous lesson where we had 2ht minus h. And then you keep doing this. Number 3 ends up being h minus 2ht. And number 4 is h plus 2ht. And you got to do this forever. So our final equation, it turns out that you can establish a pattern, and if you're clever enough, you can come up with this equation. So I just found a pattern with this, and here's our final equation then with an infinite sum. So I'm going to use I as the index. And you see for each I, there's 2 terms. There's this term and this term. The y over sigma y is common to all of them. We have all this grouping, same as before. This is same as before. And so each of these is z minus some source location, z source. And then this is z minus a different source location. So we have to just figure all this out in terms of an index. It turns out that you get 2 of them, one with z minus h minus 2iht, and then one with z plus h minus 2iht. So that's all there is to it.
But how can we model an infinite number of sources?
Obviously, you can't put an infinite number of sources in Excel or something. So what do? We usually only need a few of them because, let's take this one way up here, which would be number 6. Notice that it is spreading, but it doesn't hit the ground until way, way down at very large X. So if we're interested in X's here, we may only need a few of these image sources. We need a few of these to make sure we get all the ones that hit the ground. But unless we're really far downstream, we never actually need these other ones. So in practice, we might use 5 or 6 of these sources, but not all of them, obviously. You can't do an infinite number. So here's the good news. I'm not going to make you do this. I used to give this as a homework problem, and it was a real bear for students to try to put 6 sources in and do all this in Excel. Or I've done it myself, and it takes a lot of work. I'm not going to make you do that. It turns out that we have an approximation for this kind of a fumigating plume that is much easier, that I'll talk about next lesson. For now, I do want you to be able to figure out where these things are, though. So let's do a quick example. We have a plume with an elevated temperature inversion and a reflecting ground. So when you have that situation, we have this infinite equation here with an index I equal negative infinity to infinity. I should point out that you're including 0 in here. I is an integer, and it goes from negative infinity to infinity. So you'll get to like -2, -1, 0, 1, 2, etc. out to infinity both ways. And typically we only need, say if we were using 5, we would only use these 5 i's. Each I, however, has 2 sources. That's what makes this even more complicated, because there's one due to this term and there's one due to this term. So you have to be really careful when you do this. So let's suppose we have a stack that's 60 meters high. The plume gains an additional 10 meters. So we know that H is equal to 60 plus 10 equal 70 meters. And then it says there's an elevated temperature inversion above the plume, and the temperature inversion is at 95. So HT is 95 meters. So we have those values. And then what I asked to do here is find the elevations in meters for I equal -1, 0, and 1. So this is just a matter of geometry, like I said, using the equations that I just gave you. the key is, again, that this represents z minus some elevation and this represents z minus some other elevation. So you just have to watch your negative signs and figure it out. So let's do this for these different I values. When I equals 0, we have this term, the I is 0, so that just gives us z minus h. So that means that the source, z source, is equal to z minus whatever that is. So the z source is h, and then that's equal to 70 meters here. So 70 meters, and that's our real source, so that one's pretty obvious. Term 2, we have z plus h minus 2i. I is 0, so this is just z minus negative h. So this is our z source. So z source equal negative h equal negative 70 meters. Also pretty obvious because there's a reflecting ground, so we already knew how to do that. Now let's do the I equal 1 case. When I equal 1, this term becomes z minus h minus 2, I is 1, so minus 2ht. And so this is equal to z minus, I just collect everything in terms of a minus in parentheses, so z minus whatever, and then this guy is our z source. Z source equal 2ht plus h, plug in the numbers, and you get 2 times 95 plus 70, so this turns out to be 260 meters. And then term 2, z plus h minus 2ht, and we rewrite that as z minus, and then negative h plus 2ht. You got to watch your signs. Make sure you don't get a sign wrong. That gives us an h and a negative 2ht, so that's correct. And then that means that z source equal what I have underlined here, negative h plus 2ht. Plug in our numbers, and I get 120 meters. So far I have 4 sources, and notice what we're starting to see here is that for each I, you get 2 sources. So we only have used I equals 0 and I equal 1, and we already have 4 of these sources. All right, let's continue I equal negative 1 and do the same thing, and I'm going to pause and fill some of this in to save time. So doing the exact same thing when I equal negative 1, we end up with the first term giving us negative 120 and the second term giving us negative 260. Now, to double check your algebra, you have to realize that since we're reflecting off the ground, anytime there's an h, there has to be a negative h. So we had a 70 and a negative 70. Pick one of these. When there's a 120 meters, you have to have a negative 120 meters, and that's what we're getting here. So that's good. Here we had a 260. Here we have a negative 260. But it's sort of in a zigzag pattern, and these aren't obvious where they are until you work it out. So you'll have to work some of this out for the quizzes, so make sure you understand with this geometry. It's just a matter of drawing it and figuring out all these different lengths, but I won't make you actually plug into this equation. So have fun with the geometry on this quiz. It shouldn't be that difficult, but you have to keep track of your elevations and your signs, especially when I is negative. You got to be careful.
Thank you for watching this video. Please subscribe to my YouTube channel for more videos.